So my name is Tom Capelli. I work for Sodius, which is the logo you're seeing on the screen. With me is Valéry, who will be taking us through a demo. So I will do a quick introduction. So Sodius is a longtime partner of NoMagic, helping them with their integration needs. So there's two specific integrations that we're interested in and we're talking about today, which is a magic draw to Rhapsody and back from Rhapsody, and to and from Rational System Architect. So those are very specific needs for specific customers doing a certain type of model in those tools. And what we're going to talk about today is actually how that was built, and that's with our platform called Cameo Workbench. So let's talk about the workbench here for a second, and we'll talk about the company and why we built this. So Sodius has been in the interoperability business for probably 16 years now, where we started off focused on purely really UML tools, and we kind of went a bit further than that into enterprise architecture tools like System Architect or a tool called Mega or Aris, and even going beyond that to the types of information we can bring in and translate. And so we've studied this problem for a long time, and out of us trying to increase our activity and improve our productivity in this domain, we concentrated our efforts on a workbench that would help us be extremely productive when mapping concepts from one tool to another. And that's called Workbench, in this case Cameo Workbench. So this tool is really geared towards the person who has to develop a mapping between two different tools. Obviously with Magic Draw on one side, but allows you to choose information to import or export from other tools such as System Architect, Rhapsody, even other Office type applications such as Excel. And Valéry will show us a bit of that. So I guess what we need to know is that Workbench is kind of a development tool. So it's for the person who understands the concept and has the need to define the way information is mapped across. There's a companion tool, which is the runtime version. So once the expert, and I'm assuming everyone on the call is kind of in that expert, they know what they want to bring across, but they want to let other users on the team execute that import or export without really changing the rules, but executing the rules as you intended them to be. Then that's a complementary product called Cameo Inter-Op. And so Cameo Workbench is really for the development side, and Valéry is going to take you through how we actually build these mappings, and then she may tell you how to deploy it into this runtime environment for the rest of your users. So go ahead and watch what Valéry has to say, and if you have any questions, please jump in, and I think you can chat them to us, and towards the end we'll come and we'll try and answer as many questions as you want. So here's Valéry.
Thank you, Thomas. I hope everybody can hear me. I will do the presentation, and here is the agenda of the presentation. So I want to explain you first what is Cameo Workbench. So who needs Cameo Workbench and how does it work? After, I will briefly explain one of our customer experience. So it was with ACORD, and we've created for them a special, some special services. And after, I will do a very simple example to show you how to transform a PetWinnet model to a Magic Draw model. And after, we will do a conclusion. So first, what is Cameo Workbench? Cameo Workbench, as Thomas said, is the development environment for the realization of configurable model-to-model transformation. It is an Eclipse-based environment. You can develop model-to-text as well as model-to-model transformations. It is a domain-aware declarative functional mapping statements. You can generate your application. And also there is some debugger. You can debug what you are coding. Who need Cameo Workbench? If you're a lead architect supporting several projects for stakeholders demanding similar content in different model notation, you need Cameo Workbench. If you're an engineering technical manager responsible for multiple architects using different tools to craft similar systems. If you're a model-based systems engineer responsible for integrating requirements, enterprise architectures, software system, test cases, and traditional documentation. If you don't have time or money to waste on expensive Java skilled software programmers with unique awareness of the details of the models of many ALM or PLM tools. If you are encountering the same transformation challenges over and over, and this is not going to go away soon. How does it work? So as Thomas said, Cameo Workbench is coupled with Cameo Inter-Op. So with Cameo Workbench, you will write your rules, you will run the rules, you will trace and debug the logics of the rule, and after you will deploy your rules into Cameo Inter-Op and you will run them from Inter-Op. Right now I will do a small demo with an example of a service that we've created. So the service transformed from System Architect DODAF 1.5 Encyclopedia to Magic Draw UPDM2. So it includes graphical information and of course semantical information. So how it works, first we connect to System Architect through the COM API to read the semantics and to read the graphical information, so we call that a reader. Then we convert the data using the transformation rules, and we create a UML 2.1 model that MagidraW can read. So we call that a writer. We use a writer. So I have a small video to show you in order to explain you how it is working with Cameo Inter-Op. And after I will show you the rule set on the Cameo Workbench. So what we do there, we have a DODAF 1.5 model into System Architect. So here, as you can see, there is an OV2 diagrams. So we have some operational nodes, and they are linked to operational activities. So it is a typical diagram that you can do with System Architect 1.5. And so here we see the link between the operational node and the operational activities. So of course in the model there is some other diagrams, but I want to focus on the OV2 diagrams. So here you have Cameo. Here you have Cameo Inter-Op. So you can select the model you want to transform. So we call that the input model. And then there is some parameters in the service you launch. So here we can select the diagram we want to transform. So here we are selecting, it is possible to select the diagram to transform. We choose to transform the complete model. Here we are selecting the MagidraW output model, and we can also create some traceability report. We have some other arguments for the service. For example, we can generate some special classes for standard DODAF elements or for non-standard DODAF elements. And also we can import the SV-A, SV5B, or SV6 matrix. So what we do here, we are transforming from System Architect to Magic Draw. This will create a Magic Draw model that we can open with Magic Draw. So we are doing our transformation. Our Magic Draw model is ready. So we can now open it through using Magic Draw. So it is opening my Magic Draw model, and I can check the model the diagrams I have created. Here I have a div2 diagram, and here I have a div3 diagram, and my focused diagram was an OV2 diagram. So as you can see, we have recreated the graphics and the semantics of the diagram. In the left side, we can see the System Architect diagram, and in the right side, we can see the Magic Draw diagram. So this little video was just to explain you what we want to do. So now I want to show you what we have into Cameo Workbench to create that, the tool we have to create that. So as you can see here, I have Cameo Workbench opened. It is an Eclipse-based environment, so if you know Eclipse, you won't be lost. We have created some transformation, so from System Architect to UPDM to Magic Draw, and those transformations are accessible for the user. And here I have the example of System Architect. I can open the project, and I can check the rule I have. So here I have the rules that transform from System Architect to Magic Draw. And I have the main rule, which is, no, it's not this one, it is this one. I have the main rule, which is there, that take in entry an input model, which is a System Architect model. And it will create a UML 2.1 model. So the rules have already been created, and they are creating diagrams by diagrams, because the System Architect model is diagrams. How to say that? It's diagrams leaded. I don't know if it is correct. And if I want, I can browse my System Architect model. I can see the diagram I have. So here I have the OV2 diagram. I have 7 symbols in the diagrams, and a symbol is associated to a definition. And here I can see that I have symbols that represent an operational node, and it is connected through a need line to field definition, etc., etc. I can browse my model, and I can do the same thing, exactly the same thing on the Magic Draw model I have created. I want to create. So here, what I want to show you is how to run the transformation. So I've created a launch configuration. And the launch configuration will allow you to run your rules, to see the result, and also to debug, because you can put some breadcrumbs. So here I have a launch configuration from the rule for the rule set System Architect to Magic Draw. It takes an entry a model. Here I'm using the $sample model. And I will create a Magic Draw model, which is, in fact, a UML 2.1 model. And I run the transformation. And here what happened, it is exactly the same thing than what happened when I run the service through Cameo Inter-Op. In fact, it is the transformation and the creation of the elements. So here it is reading the the Magic Draw, some Magic Draw profiles. So here I'm reading the UPDM profile, I'm converting the system architect element, I'm creating some business process diagram, etc., etc. Once the model is created, I will show you the Magic Draw model through in Cameo Workbench. So here my model is created now. I can open it. So it's reading the model. Sometimes I have some messages. It is reading the model. And I can check the structure of the model. So here I have a way to see the model. If I want, I can say, no, I don't want any working set. I want to see the element flatten. So I want to show you the OV2 diagram created. So it is more a diagram than a class. And it was, I can't remember the diagram name, it was Command Battalion Code Connectivity. So it is this one. I have a diagram created and it has 17 elements, some graph nodes. And the graph nodes are linked through a graph edge. So here I have an edge between command central and send order to field division, etc., etc. Like we've done for the system architect model, we can browse our Magic Draw model using Cameo Workbench. So it is really useful when you want to debug the logic and to how to say that, to well, yes, when you want to optimize your transformation. Also here I have so of course I can see the properties of my elements in the properties view, and I can also see the diagrams. So here we have a special view which is called Interchange diagram. So it is really useful to see the aspect of the diagram. And also, of course, you can have a look on the meta model. Here we have the UML 2.1 meta model, which is not the easiest meta model we can have, but here we have a class, and we can browse, we can navigate into the elements of the meta model to see what we can do, to see the association we can have, and also we have some API that have been created to yield the creation of the elements. Here it was what I wanted to show you really briefly on what we can do with Cameo Workbench. And we've used also Cameo Workbench for one of our customers that wanted, that has really that had a problem because they wanted to provide some models to its member. So the model were created with the Magic Draw, and they wanted to more easily exploit its contents. So for this customer, we have created 3 special services. One service which is called Magic Draw to Cameo Data Modeler, which is a service that automatically creates a data model from the information model, including diagrams. The data model is implemented in Cameo Data Modeler. Another service which is Cameo Data Modeler to Infosphere Data Architect. This is a service that automatically creates an IBM Infosphere Data Architect from the data model. And another service which is Cameo Data Modeler to Erwin, which is a service that automatically creates an Erwin model from the data model. So in the bottom you can see the 3 services that has been created with Cameo Workbench and integrated into Cameo Inter-Op. Our next subject will be an example of a transformation, and this is really a simple example to show you that when you have two meta models and when you have when you know what you have to transform into what, it is possible to create your own bridge. My example is to transform a PetriNet model. So just briefly to explain you what is a PetriNet model, you have four main concepts which are a PetriNet. It is my root elements. A PetriNet has some places. Between places you have an arc and you have some transitions. The relationships between the elements are you have a PetriNet that has several arcs, a PetriNet has several transitions, and a PetriNet has several places. An arc has a source node and an arc has a target node. And also you have some features, so a PetriNet has a name, an arc has a name and a number of tokens. A node has a name and an ID, and a place has a number of tokens. So what I've done is I've created the PetriNet model into Magic Draw. So I have 5 classes: PetriNet, arc, node, transition, and place. The classes as attributes, so PetriNet has a name, an arc has a number of tokens and an ID, a node has an ID, a transition and a place, which are a kind of nodes, as a name and ID, because they inherit from node, and a place has a number of tokens. And of course you have the relations between the elements, so PetriNet has several arcs, a PetriNet has several nodes, and there is some transitions between a node has some output arcs and has some input arcs. And yes, and so what we've done with Cameo Workbench, we have imported this meta model. So we have created our own meta model and we have imported it in it. So there is a special tool to import a meta model from an XML file or from an ACORD model, an ACORD file, etc. So it is possible if you have an XML file. And here I have the Java classes for the meta model. And if I export this plugin into my installation path, I can see the PetriNet model here into my model view. And of course, I can iterate through the elements. So what I can see, I have my PetriNet, which is my root element. It has a name, which is a string, and it has some nodes. So a node is a kind of place or a transition. A place has an ID, has a name, and has a numbers of tokens. Here you can see that numbers of token is an attribute in blue, which means that it is only a place attribute. It's not a node attribute. It's not inherited from node. A transition has so an ID, a name, and has some input arcs and output arcs. And an arc has a source, a target, a number of tokens, etc. And next step is to be able to read some model in order to populate the PetriNet meta model. So what we have here is that we have created our accessor. So just briefly to explain you what is an accessor. An accessor allows you to connect Cameo Workbench with external tools and files. So there is several kinds of accessor. For example, you have a Rhapsody accessor, and we provide a file accessor, an accessor that can read some RPY file, and an accessor that can connect directly to the Rhapsody API. We also have an accessor, a system architect accessor, etc. We have Magic Draw accessor, which is a file accessor. It creates and reads MD XML file and MDZip file. And we have some other accessor, of course. And what I've done to be able to read PetriNet files, so there are XML files, I've created my proper accessor, my own accessor. So it is what you can see here. It is an accessor. It is really a simple accessor that read and parse XML files. So in entry, I have a file, and I want to create a model. And for example, here, if I do open model, and I want to read an XML file, I have for my PetriNet model, it is this file, and I click finish, and now I can see my, so the example is a swimming pool, but I can see my PetriNet model, which has some places and some transition, and I have a transition, an output arc from changing room to this transition PK2, and another output arc to dressing. So in fact, I have a transition from changing room to dressing, etc., etc. So here what I've done is that I've created my accessor for the PetriNet meta model. And now what I want to do is to transform the PetriNet model to a UML model. So I think, yes, I have some slides to explain what we will do. So a PetriNet model is a kind of state machine. So that what I want to do is to create a state machine. I will transform any place of the PetriNet model to a state of the state machine. And the couple transition on arc will be transformed to a transition. In this example, I haven't created the graphics, but it is possible. Knowing that in my PetriNet example, PetriNet meta model, I don't have any graphics information. So we are just dealing here with semantic information. Let's do a demo. So I close everything, and what I have is that I've created projects here that do the transformation. So I have some input model, which, for example, here I have my swimming pool, and I've made the transformation step by step, and I want to show you the steps. The first step is to declare the rule set and to create a main rule. So the rule set will take in entry a Petri model, which is a PetriNet meta model, and we create an out UML model. So here, PetriNet and UML 2.1 represent the ID, the identifier of the meta model used. I have my main rule, and my main rule will take the PageNet root element, and if it is not null, it will create a UML model. For this UML model, it will create a nested package, which has the name of the PageNet model, the PageNet object instance, and it will create a class because a state machine has a parent class, and this class is also called like the PageNet element. And in order to be sure what I'm doing is good, I've created a launch configuration that will test my transformation, my first step of the transformation on the swimming pool model. I run the transformation. So, and I have the result, which is a model that has one member, which is a package called swimming pool. And this package has a class, and that's it. This is our first. Second step is to create the state machine. So here we have the second step. As for the first step, we have an entry, a Petri model, and we are creating a UML model. The first part of the rule is the same. We are creating a model, a package, and a class. But we are calling another rule, which is create state machine for the class. And the create state machine rule will take in entry a class, which is the UML class, and the PageNet elements. So what we do is for the class, we create its own behavior, and the own behavior has to be typed. So here it is a state machine. It could be, for example, a flow chart or something like that. And also the own behavior, the state machine will be called like the PageNet element. And for the state machine, I have to create a region. So, like this, I create a region for the state machine, and the name is always the same. Also, to verify that I'm not wrong with my transformation, I'm running the transformation, and the result is that I have my model, I have a member, I have another member, which is a class, another member, and here I have created a state machine, and it has a region. Next step now is to create the state for the state machine. So the first part is the same. I'm creating the state machine, but I've added another step here, which is create the state. And what I'm doing is that for every place in my Petri model, I want to create a state. For each place in my Petri model, I want to create a state. And here I'm creating the state. So I create the state here. So always I have the API to create it. So the state is created for the region. And also we are using what we call a transient link to clearly identify the step for the place it comes from. Because I will need this transient link later in my transformation to identify the source and the targets of the transitions. Like always, what I do is I check that I'm doing good things. And it is step 3. So my region here has 9 states. And the states, what are the attributes of the states? It is just the name. So this is a really simple example on how to create the elements. And the last step now, at least for the simple parts, is to transform, to convert the transition. So the first part of the step, when I create the state machine, I create the transitions. And like I've done for the places, I want to say for each transition in my Petri model, create a transition. So it is a little bit different than for the states, because between the places and the transition, we have some arcs. So what I want to do is to take the first source of for each, in fact, for each transition, even if I have an arc between them, I want to create a transition in my system, in my UML model. So what I do, I take the output arc of the transition, and I take the input arc of the transition, and I say the output arc as a target, and this is the target of my transition, and the input arc as a source, and this is the source of my transition. And for them, I'm creating a transition, and the name of the transition is the source underscore target. And after, what I'm doing, and it is here that I'm using the transient link, I'm saying that the source of the transition is the source of the state. It's a state source, sorry. And the source of the, on the target of the transition is the target state. And what I'm doing is I'm checking my transformation again. Okay. And here is the result. My region has now 22 members, and I have the transition between the states. So here my state has 2 incoming transitions. Now let's do without coding. So my state has 2 outgoing transitions, 1 transition from changing room to dressing, if I check the source and the target, and one other transition from changing room to weight. And here I have the basis of my state machine. Of course, to be complete, we should create the graphical elements, etc., etc. But they are not. I don't have information in my Petri model, which is really a simple model, a meta model. And the next step now, I don't know if you remember, but some features are not transformed in the PetriNet model. I don't know if you remember, but my places in my Petri model has some numbers of tokens. And here, if I keep the transformation like this, some features are not transformed in the UML due to a gap between the language, because the state in the UML model does not have the numbers of token attributes. So I will use a profile to extend the UML in order to express the additional feature. So like I said, we will focus on numbers of token place. And I have a demo for that, just to show you what we've done on Valéry. In fact, to express the numbers of tokens for the place, I've created a profile which is called Petri profile in Magic, which is stereotype. No, I have a stereotype. Sorry. Which is called place, and which is applied to a state, and this place has an attribute. This stereotype has an attribute which is token number, numbers of token. And I want to use this profile to represent the numbers of token in my UML model. Again, I've prepared the rules to do that. And something which is a bit different is that we are taken our Petri model in entry, but we are using the Petri profile as an input model. So what I'm creating is I'm loading the Petri profile and I'm creating a new UML model. And what I need to do is I need to apply the profile to the model I'm creating. So like I'm running the transformation and I'm having the Petri profile in entry, I'm able to detect the Petri profile and to apply it to my model. And once this is done, I can stereotype the state here, and I can say my state will, so I have to recover first the place stereotype, and after I can apply the stereotype to the state, and I can set the value to the state. I can set the value token, numbers of token or token numbers to the state. Let's show you the result of that. Here is what I have. So I'm running the transformation. So it's a little bit heavy because I'm running the transformation in a full magic draw model. And here is my result model. I still have my region, which has 22 members, but I have here a state which is stereotyped place. I can see the stereotype here, and my stereotype has a tagged value, numbers of token, which is 1. This one has another tagged value, which is numbers of token, etc., etc. And to finish my presentation, I want to do a quick conclusion, which is why do you need a Cameo Workbench? Because it reduces the need from prima donna rockstar programmers. It saves money, it saves time. You can build reusable transformations. The model transformation done by hand is time consuming. You can do error, and it's skill demanding. That's a high cost of a long time. This has a large net present value economic costs. Model transformation with Cameo Inter-Op, Cameo Workbench is fast, less error prone, lower skill demanding. It has a low price. This has a small net present value economic cost. And it is a low cost to implement with high immediate reduction in cost yields and a good ROI. So I see a question. In general, how much optimization is required to get good results? So, so from Rhapsody to Magic Draw, yeah, we have I think we have a quite good transformation from Rhapsody to Magic Draw, knowing that we are using the XMI toolkits. So we are using the the XMI toolkit of Rhapsody. I think we have good results. It is always possible to fix the issues if we have some. So I don't know if the answer is good enough. In fact, we are the previous version of Cameo Inter-Op and Cameo Workbench. We're using an old version of the Rhapsody to talk about we were using an old version of the XMI toolkit, and the next version of Cameo Inter-Op, which will be in March, will use the last version of the XMI toolkit. So at least we benefit of the improvements done in the XMI toolkit. OMG, I don't know. I can ask. Yes. I can ask if somebody will be there.
And Valerie, this is David. I'll answer that. Yes, No Magic will have its normal delegation there. So our CEO Gary Duncanson, our COO Pete Iannacci, and also our Director of Engineering Charles Gailey will be in attendance, as well as some of our folks from our Lithuanian group and some of our development heads over there. So we'll have both executive management and technical managers there in Ruston next week. So Christian, make sure to stop on by and we'll be happy to talk to you. Are there any other questions for Valerie before we close out? All right. Valerie, is there anything else that you'd like to comment before we sign off?
No, just I was happy to do the presentation and did not hesitate if there is some question.
Absolutely. And we'll make sure to post not only all the questions and answers online here in the next few days at nomagic.com, and I'm not sure, Valerie, if you guys posted as well, but we'll make sure that all the attendees find out where they can find this information after the fact, so you can rewatch anything and see this webinar again, or so you can share it with other people that might not have been able to attend this morning. But thank you so much for attending, and we appreciate everybody for taking the time to join us this morning.